What is going on, everybody? I know it's been a minute since a Jeff the G1 update. I've just been doing other things, but I did finally get around to it, and actually the delay probably saved me a little bit. I'll talk a bit about that later. But in this video, I have a reinforcement learning policy. I used PPO, and it's still a very tiny model. It's a 2x64 model. The entire model file is like 184 kilobytes. It's just itty bitty, okay? And we're actually going to load it onto the G1 live right now. So prepare yourself. I'm going to hit the R key and load it on. There it is. It's on the G1. Pretty impressive. Anyway, that's all for now. I'll see you guys later. No, just kidding. Okay, so we've got the policy on there. I'm going to show it to you live now. Everything is going to be very slow. It's intentional. This robot can move very fast. I'm just moving it very slow because we're running an arm policy. Like, I'm controlling every single joint, and things go fast if you let it. I don't want it to. So what I've done is I've got an arm policy that just seeks out a target, okay? And then it seeks out that target based on the current positions of the arm, so the current joint positions of the arm. And then I have a program that all I do is I press keys on the keyboard to control the target position in space with up, down, left, right, forward, and back. So essentially what that translates to is I can control the arm or the hand position in space with up, down, left, right, forward, back. Okay, cool. So I'm going to start hitting keys, and hopefully it works long enough. There's lots of little gotchas here. We'll talk about them as they happen because they will almost certainly happen. Let me see if I can find where I have... What's going on here? Oh, okay, I just can't see it. I couldn't see it yet. So, okay, so we're moving, that little red ball kind of marks where is the target. So I'll keep raising it. I'll put it a little further forward here for him. Okay, so as you can see, the actual G1 is mapping to the simulated G1. There's no need for this other than right now I'm using the simulator to just simulate this position in space. Later, we'll come back to using the camera, the LiDAR, whatever else, the depth sensor, all that kind of stuff. Or some other way entirely of determining what, where are we trying to get that hand in position in space? Because you could also use something like it could just be a remote control that's just, again, we're just trying to control that hand to go up, down, left, right, forward, and back. And for some crazy reason, that is not available in the SDK, in the firmware for the G1 out of the box. So it has to be created. Like, I just feel like this is a bare minimum requirement. So anyways, let's show some more before something goes wrong. So we'll keep moving it up, 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 up. As you can see, that's working pretty good. We can go forward. I can never remember which key is forward and which key is backwards. It's kind of sad. Maybe that was too far. Let's bring it back. Let's go a little to the left, a little to the right. Then we'll come back a little bit. We'll see if he can catch himself here. That was interesting. Interesting path to get there. But one of the old policy where I just like manually trained it, one of the things it was pretty bad at was if it was previously in a position that required the elbow to be out and then it needed to bring that elbow back in, it was quite bad at that. And then vice versa, it was bad at that as well. It was bad at a lot of things, to be fair. It was pretty cool that it worked, don't get me wrong, but it was bad at a lot. But this policy, I mean, again, it's like you get the benefit of millions of samples, okay? The first few million, there's a lot of bad samples in there, but as time goes on, the samples are just getting so good based on that reward, policy that, or the reward function rather, that eventually it works out. Now, one of the things I was trying to make happen was I really wanted it such that if the hand was open, like it is at least in the sim, I wanted it to always be capable of grabbing a bottle, right? So no matter where it was, I wanted essentially the hand, right, to be parallel to the ground, and then the fingers to be perpendicular to the ground, right? I did have a little bit of regularization in there trying to incentivize that, but obviously, as you can witness right now, it just wasn't enough. And that's why, like reinforcement learning is just real fiddly in that way. There's just a lot of scenarios where you kind of have to, you just kind of have to keep trying certain things. And like the wrist is much better than it was when I had none of that regularization. And then I really hoped that if I let it train long enough, it would just keep getting better. But really this is probably about as good as it was within the first few million steps. So yeah, so be it. I'm trying to, like, I literally like have positioned this camera to focus on the G1, and I even have the G1 getting the light. And it just keeps focusing on me, so I apologize. But as you can see, I mean, damn, it's a pretty darn good model. I'm super stoked with this model. I think it's pretty good. Like I was saying earlier too, let me go back over here. I just don't want him to die too quick. Everything could be a whole heck of a lot faster. So for example, we can change the rate to be a little faster, and we can change the speed to be half speed. Hopefully this doesn't freak out, but again, I have the e-stop, the remote is on. I've changed my entire procedure to basically, that's why, that's another reason why I like that boot up sequence, using the position of the G1 and then mapping it to here, because that forces me to always boot up or essentially get my G1 to a balanced stand with the remote, which forces me to always have the remote on and like ready to go. So anyways, we are faster. Let's see what happens. Yeah, so you can see he's quick. He's a quick boy. And this is, again, we're at half speed, and I think we can actually go quicker on the rate. Yeah, we can go all the way down to 5 milliseconds on that polling rate. So, so just for the record. And we're running also at half speed for like the, what is that? I can't remember if that's actually torque on the SDK. Someone can comment below if you know. But anyway, those are two things that you can kind of tweak. But yeah, as you can see, he's pretty quick. Like you can move up and down, all that. You can go left, right. Again, that's pretty fast. I can't imagine many. Oh, did we lose it? No. Oh, there we go. That's the problem with speed, is eventually you're going to piss it off enough, probably. So that's one of the things that can happen, is if the motor is trying to get to a position. So it could have been any of the motors. I wasn't looking closely enough to be able to tell you which one. But it seems like if any of the motors are trying to do a thing long enough and they can't do it, the entire arm will just give up. And the only way I know of to get out of that state is to reboot the robot. So I'm going to go ahead and do that. Oh, also, I can show one more thing before I do it, and while we're rebooting it, I'll show another thing. So take note. This arm's already kind of damp, but he is standing. You'll see him fall a little bit, and that arm, you'll see that arm fall. But in 3, 2, 1, boom. That robot goes down. That's instant, okay? When I hit the buttons, it's instant. So now I'm going to turn Jeff off, and then I'm just going to reboot him, and thanks, dog, and we'll talk about some stuff. So, despite my hiatus, and while I was working on the reinforcement learning algorithm, one of my colleagues on the old tweeters sent me this video. It's kind of funny. Sorry, I'm going to laugh. Luckily, no one was hurt. The G1 apparently was a little hurt, but yeah, here's the video. Oh, these are not the same people as before, where there was an H1 that freaked out on some people. This is totally different, just for the record. Don't put your hands in there. Don't do that. Definitely don't do that. The box is so funny.
Oh my god! What the fuck is that? I'm so sorry.
What the fuck did you guys run?
Oh man, I feel that. I really do. I'm sorry for all these people. I'm sorry for that G1, but that's a pretty funny video. One of the things that he told me was the latest firmware, so the one that your G1 can run, okay, like where it can like actually move so fast it runs. Everyone's been grabbing that firmware, but one of the changes apparently is when you press L1A for like the damp mode on your robot, it is not an instant. Oh my god! Oh, see, okay, here's a perfect example. Scared the crap out of me. And this is a perfect example of how fast those arms snap. Now I don't have to find some B-roll to show you. So the reason why that happened is, and this is how easy it is to just smack the out of your face or something, or like lose an arm. Because, well, you're not going to lose an arm, but you're going to hurt yourself. You could definitely break a finger. So the reason that happened is that's the state that the robot or the simulator is in. I should have reset the simulator, but the moment I told him he could stand up, that's what he did. Cool. Perfect example. It's just so easy to fall into this trap, and I wish the default speeds of these motors was different. And then you might be thinking, oh, well, dummy, you set that speed. Well, now it's gone, but you set that speed up here. No. That speed is a software speed that I'm setting on top of the SDK. The SDK speed, like that speed is actually a speed that I'm like slowly iterating through. Whereas that speed that you just saw right now, that's just the speed of the G1. Like if you don't do something about it to set that to like change, it's not like the SDK where you can set like this is the global speed of this robot. It's that's just the speed of the robot. I don't know how to put that. That makes sense. As I say it, it sounds weird, but anyways, I don't like it. But anyway, I'm not sure about this. I guess this is because I reset the robot and I didn't reset this. I don't know. Let's see if we can still move her. Yeah, we still can move the stuff. So at least we can show a little more of the guy. I mean, he moves so violently. Oh no, actually, I bet the fingers probably moved on the boot sequence. Let me get back out of frame. Let's see if I can do like this maybe or something. I just wish it would stop focusing on me. Is he not even be able to reach that? Okay, we'll bring it. Oh, he already died. Oh, I don't know why. Like, what was he pissed off about? I don't know if it's the vibration or what, but if it's the vibration, if anybody has a G1 that knows, is it the vibration? Like, is that what it's pissed off? Like, I just don't know. Like, I don't know. Is that like a thermal setting? Is that a force torque setting? I just don't know. Because if it's the vibration, we can detect that and just like stop that. And maybe that's what I'll do from now on the front end. I don't really know. But anyways, lovely. Okay, before I forget, I am going to, I'm going to break there. So let's talk about the training. I've got two things shown up here, only because like I trained a bunch of models, but I just have two because there's not much point to show too much of the other ones. But basically the red here is the, this was when I was actually targeting the wrist instead of the palm. Because I thought the wrist would make more sense because I thought it would be like right at the edge of the hand. And I just thought, yeah, that's where you would want to make contact with the thing. So I thought that would be a better spot. But no, you should use the palm. I know that's just going to blow some of your minds. But anyway, there we go. So you can see it better. But anyway, that's just time FPS. Nobody cares. So let me see if I can pull up like this. Maybe it'll be better. I don't know. The main one that we care about is the actual policy loss, which is here. So as you can see, again, green is the palm. That's the one that we were just running on the simulator and all that. In that case, I'm just trying to figure out how I can align this and my camera not be in my face too. But anyway, whatever. So as you can see, loss is going up. So that's why I stopped it. I do think though, like looking at everything else, like everything else was actually looking, in my opinion, like pretty decent. Like maybe if I just kept going, it would get better. But there's other things I want to tweak anyways, and already this was taking like essentially almost 24 hours to run. I need to improve the multi-processing and all that stuff too. So that's for probably future. That'll probably be the very next thing I do because I would like to be able to train much longer, much more robustly, and then also have essentially sweeps where I'm training based on a whole bunch of different parameters, and it's just so much quicker than training like one model at a time or something. But even then, like I might just train like multiple models at the same time. Rather than worrying about multi-processing at all, because essentially you can do a 10x speed up, just train 10 at the same time. So anyway, but yeah, everything was looking pretty good. And like value loss was also going down pretty well. So it was really just that policy loss right there. So maybe it would recover. Maybe I just need to change the learning rate. I don't know. If anybody's a reinforcement learning guru, feel free to leave below. To get to this point, I wanted to first confirm that the joints were all correctly mapped, like joint to joint, and that the actual simulated positions and the real positions were close enough that we could even fathom doing sim to real in the first place. It's definitely not perfect, but it was looking good enough. So the problem is if any of the joints are off, even just by like a little bit, the downstream impact through all of those joints in the arm can be pretty substantial, and then going from simulator to real just wouldn't even be possible without tweaking the simulated values. It's definitely not perfect here, but it was looking good enough, I thought, for an ARM policy. So with that confirmed, we're ready to actually train a model. My overall idea was that all you need in a model is something that seeks out a target position, because from here you can essentially just go from any position to any position. But also it could be folded into things like higher level stuff like tracking an object live, or even doing something like I showed here where we're actually moving the target, but we're moving it with up, down, left, right, forward, back. So it essentially gives us, at the end of the day, the ability to move the hand in a very abstract, high-level way, up, down, forward, back, left, right. Anyway, you get the idea. So to actually train a model to do that, there's obviously there's tons of options for RL algorithms. I started with PPO just because I've had success in robotics with it before. It's usually pretty quick and easy to train. It's not a very fiddly or finicky algorithm, so I just started with that. I'm using the stable baselines 3.1, and then I can change it going on, and I might still try some of the other algorithms, but there's just so many things to tweak and fiddle with anyways already, even with PPO, even though it's not super fiddly, but there's still a lot of stuff I have yet to try. So anyways, I just picked PPO purely for that. I've had success with it before, so why not again? I think till the end of time, reinforcement learning environments are going to be predominantly molded around the OpenAI gym formatting, where OpenAI was actually open back then. If you're not familiar with reinforcement learning, this is basically like OpenAI kind of got its start with reinforcement learning, the environments. They had like a lot of really cool ones, and this kind of concept where you basically have some environment, you send in your action to that environment, and then in response to that environment like object, you get basically the next observation from the environment. You get the reward if the episode was over or not, and then any extra infos if your environment, throws them out. This kind of like structure is pretty much what you see in all reinforcement learning environments. It's what I have personally used every single time I'm doing reinforcement learning. It just works really good. It's a great framework for thinking about reinforcement learning, and then it makes it really easy to like swap in different algorithms and like change things and tweak things, and it keeps things organized, and it just seems like this is what everyone uses and will likely seemingly always use for this kind of thing where you have like a reinforcement learning environment. Now, in our environment, our observation space is just 24 values. This is comprised of first the 7 joint angles in the actual, like the arm that we're trying to move, followed by the 7 joint velocities. So that's 14 up to this point. Then we have the XYZ position of the hand in that Cartesian space, so 3 more values there. We have the goal position in space, XYZ, so 3 more values there. And then the delta vector of the current position to the target, so what is the total movement required essentially if we were to take a straight line there. And then, so that's 3 more values. And then we have the step, essentially fraction for the episode. And this adds up to a total of 24 values. In the action space, it's even simpler. We have just a 7D vector, and this is just incremental joint commands, period, for each of the joints per step that we want to take. So then the end result, per episode or per, total arm movement that we want to take to reach some target, this is going to be just a chain of these incremental moves to get to that point. And then the episodes themselves are terminated by either, the ideal scenario is the goal actually got reached. The hand got within 2 centimeters, which also is tweakable. You can make the precision be whatever you want. I just thought 2 centimeters, that's going to likely be good enough. You can get very precise if you want, but again, the more precise that you're going to get, you're going to need to make sure that your environment, like the sim and the real robot, is tuned very tightly. I went with 2 centimeters because I have personally seen that it's often off by 2 centimeters, or it can be off by about that much. Plus, if you're trying to get really, really precise, you might get more like wiggles and stuff like that, like in all of the, along the whole arm as it's trying to get to this like really, really exact position that it may or may not even be capable of getting to. So that can be a problem. Besides actually reaching the goal though, you can also terminate due to self-collision. So like in training, we obviously don't want to train an arm policy that gets to the target by going through the body or through the head or whatever. So any sort of self-collision or clipping or anything like that, that terminates the episode. Then also if a joint limit gets hit, so if it goes to the maximum of some sort of joint position, then we also terminate there. You should never be getting to the maximums. This is another thing that I may end up tweaking, because there's certain joints where, like, if I'm at the max of that joint, something has probably gone wrong. The main one being the shoulder pitch joint. You really never want to fully bring down that shoulder and like have the elbow hitting the body. There's like never a good scenario for that to occur, but the G1 is fully capable of that occurring, and there's just no good comes from that. So unless you really do want to rip off the front plate, but I can't. I never ever really want to do that. And then beyond the joint limits and terminating and all that, the other reason why we can terminate an episode is it's just simply taking too long to get. And interestingly, this is actually calculated dynamically based on the delta from the current position to the target position. And this is not something I would have likely thrown in here as a suggestion or an idea of my own. This is actually Codex and O3 just like threw this in there. And so it seems to be working, but there's also some tweaking that we could potentially do here. But anyway, cool. So again, the algorithm that I've used so far is that PPO. It's just an on-policy actor-critic style model taken straight from Stable Baselines 3, which is pretty awesome. I do have a series on Stable Baselines 3 on the channel if you want to learn more about that. But basically, we just take those 24 observations. It goes through a 2x64, and bing, bang, boom, you have an ARM policy. So super simple. 2x64 is tiny. Like I said before, I want to say the files are like 150 kilobytes or something like that. It's a very, very small model. And if you're curious, this is the actual, the full model, like in, I suppose I would call this like pseudocode kind of. But yeah, overall, very, very, very small, simplistic model. And now for the juicy, most fiddly bit, that is the reward. For the reward, it's essentially a reward per step based on the distance that's a sort of like penalty to the target. You get a perfect 1.0 for reaching the target, a -1 for a collision, and then a -0.5 for a joint limitation. So like I said before, that's a reason the episode could terminate early as we reach a limit for one of the joints. And again, these are all tweakable. So that's the joint limit that's like built in, but we could set those limits to be anything that we want. And like I said, I kind of think I want to do the shoulder pitch and actually set a limit to that. Beyond that, under these like pose constraints, I'm trying to tinker with getting that hand to be level to the ground, and also the fingers, I suppose you could say, like vertically positioned to the ground, because I want to always maintain that correct grip. And at least so far, this is only really being calculated when the hand reaches the target. And it was really there's like a side benefit to this was I was often having the episode either terminate early because the wrist just kept twisting for really no good reason or bending. But then also the wrist was just doing it because I wasn't setting, like I didn't really care what the position of the wrist was. I was just trying to reach that target. The wrist and the hand was just doing really weird things. Like as it was training, it would just get into these really weird contorted positions that, yeah, they look weird, but the policy doesn't know that. And it's just trying to solve the problem that you presented to it. It's not trying to look good or anything like that. And so I wasn't even thinking about it until I saw it. And I was like, oh my gosh, that looks terrible. And like what you saw like before where the arm just kind of like dies, if you get to a joint limit and you keep trying to push things, it's just really easy for the arm to just enter that, whatever that state is, where it's just got overloaded or whatever, and it just goes completely into like a sort of damp state. And then, yeah, beyond that, the collision and the like slight deltas between sim and real are just an ongoing challenge. So like I said, kind of like the shoulder pitch, I probably also would constrain the elbow to only bend so tight. Like there's lots of times where it is useful to bend that elbow real tight, but most of the time you can actually rotate the shoulder back and accommodate for less tight of an elbow bend. But as you take away that elbow bend, you are losing certain places that you can actually get that hand to, but most of the time you can get the hand just about anywhere. And with that in mind, with that like extreme bend of the elbow, I really feel like there's almost no time when the arm needs multiple motors to be exceptionally like contorted, especially the rotators. So some of the joints are like benders, and then some of the joints just simply do like rotation. And it's like very rare, it seems to me, that those rotating joints need to do their full rotation. Like they almost have, it's not like a 360 where they can just keep spinning. They all have like stops, but it does seem like they never need to get even close to those stops. Like you could probably set all of them to have something in the middle of like maybe 200 degrees of rotation, and that's all they would need. It does seem like a lot of the problems that we're running into with like clipping and collision and the arm just giving up is the result of getting into these like maximal positions that, yeah, that's probably the most efficient way to get to the target, but it's also a really quick way to like burn out the arm, as opposed to if you just set a little more like joint limitations, you could still get to all these positions. It would just require a little more arm articulation to get there, but it would result in a better arm policy. So I think I need to do a little bit of tweaking there to like figure out, you know, what's the most balanced way to still retain all of the capability, but have a much more reliable arm policy that's not ripping off front plates or not overloading and getting to these like weird contorted positions that cause the arm to just shut off, basically. So that's basically it for now. I do want to share, I put pretty much everything up into that G1 Vibes GitHub repo. I threw everything into this like RL shenanigans directory only because like things are going to be like changing a lot still. So I just kind of wanted to keep it somewhat clean, but this entire repository is is just like very, as the note says, like it's just going to be a big mess, and I apologize for that. But yeah, if like you want to use any of these, just be advised you're going to need to like move essentially everything in this directory into the root directory. It's just the root directory is already full, and even this directory doesn't have all of the things that I probably should have in here, but I think it should work. But yeah, I mean, you can open up an issue or send me an email if you think something is like outdated or whatever. It's just so hard to like maintain a project like this where there's like so much going on. Because like if all you're interested in is the reinforcement learning, then you don't really need the LiDAR stuff. You don't, or necessarily, but you don't need like all of the stuff that goes into like building this little program. So anyway, but you're gonna need. I think we slightly modified the Unitree SDK, so you would need that. I'm trying to think of what else, because I've stopped using the hanger boot sequence. I'm using the remote to get to position. I think that's a much more reliable way to get to that position, but then also it is, I can't remember if I brought this up, but it's also a great way for me to enforce having that remote be on. So if my method of getting the robot into its starting position involves like having the remote be on, like I have to have the remote on to get it into that position, then it's always available to be an e-stop as well. So I kind of like forcing myself to have the remote around. So anyway, I don't think you would need that. I'm trying to think of like what else you would need from here to do the, I really don't think you would need, I'm probably missing something, but I don't think so. I don't know. Anyway, if you think anything's missing, let me know. But anyways, I threw everything up there. I threw a few, I only threw in the one model. I could add a few more models in there if you really want them, but it's pretty quick to train these, so you can train your own. And if you do, if you have a really cool one, please do share it. If you train anything, you don't even need a G1. So if you train a model and you think it's really good, reach out to me, and yeah, I'll throw it up. I'll give you full credit if I end up using your model. So anyways, I think that's everything. I don't think there's anything else I really want to add in now. Questions, comments, concerns, suggestions, you know the deal, leave them below. Otherwise, I will see you guys in another video where, you know, at some point, I think within the next 3 to 30 videos, we will have that G1. It's going to be finding and grabbing a bottle of water. Yeah. Okay. Till next time.